this is for year 11 methods. We're going to look at question number 6. We asked to sketch the graph of cos x between negative 2 pi and 2 pi. On the graph, we asked to mark the points where the y-coordinate is half and negative half. So first of all, let's draw the graph. I know the amplitude of a normal cos graph is just 1, and the period is 2 pi. So when I draw the graph, I know I can essentially fit two graphs onto this, or two cycles within this domain. So I know, first of all, let's draw a maximum minimum value. So I know the amplitude is 1, so the graph will bounce between positive 1 and negative 1. And I know the domains between negative 2 pi and 2 pi. So I'm just going to divide this into 4. And I'm going to divide this region into 4. And there's a negatives. So with a basic cos graph, I know I start at the maximum, then go to the median, minimum, median, maximum. Similarly, I go to the median, minimum, median, maximum. Hence I can draw my graph by connecting the points. Looks like that. Now we're asked to mark the y-coordinates at when it equals a half. So the line y equals a half is just between here, because it's the middle value between 0 and 1, which is a half. And we're trying to find what these points equal to. So to find these points, we simply solve the equation cos of x equals a half. And I know, and half is positive, I know cos is positive in the first and fourth quadrants. And my basic angle, which yields a half for cos, is pi over 3. And that is from my table, which we should memorize. So to get my solution, all I have to do is pick up my first quadrant solution, which is pi over 3. Fourth quadrant solution, which we know is 2 pi minus theta. So 2 pi minus pi over 3 is 5 pi over 3. Now I've got the two solutions going a positive 2 pi in the positive direction. So we're going counterclockwise 2 pi. To get my other solutions, on the negative region, I simply minus 2 pi from my first two solutions. The reason being, the relationship between this point and this point is that it's one full period away. So 2 pi. Subtract 2 pi from it to get the location of the second solution. Similarly, this solution is related to this solution by 1 period. In 1 period, which is 2 pi. So if I subtract 2 pi from 5 pi over 3, I get negative pi over 3. If I subtract 2 pi from pi over 3, I get negative 5 pi over 3. So if I were to mark this on the graph, I know my first solution would be pi on 3 a half. This will be 5 pi on 3 a half. This will be negative pi on 3 a half. And this will be negative 5 pi on 3 a half. For part C, we're trying to mark where the y-coordinate is negative half. So essentially, negative half is located here. We go through the same process. Solve for when cos of x equals a half. Equals negative a half. I already know my basic angle, which yields the value of a half, is pi over 3. But since it's negative, we're looking at solutions in different quadrants. So namely the second and third quadrant. So my solutions would lie in the second quadrant, which is pi minus theta. So pi minus pi over 3 is 2 pi over 3. My third quadrant, pi plus theta, pi plus pi over 3 is 4 pi over 3. And again, the solutions are related by one period. So if I want this solution, I just need to subtract one period. If I want this solution, I need to subtract one period. So 2 pi over 3, or 4 pi over 3, we'll do 4 pi over 3, 4 pi over 3 subtract 2 pi, we should get negative 2 pi over 3. 2 pi over 3 subtract 2 pi, we should get negative 4 pi over 3. So all I need to do now is to label my solutions on the graph. So we've got negative 2 pi over 3 a half. We've got negative 4 pi over 3 over half. Should be here. Negative 4 pi over 3 half. Just rub that under it. Negative 4 pi over 3 a half. Negative 2 pi over 3 a half. 2 pi over 3 a half. And 4 pi over 3 half. And that is how you draw the graph with the corresponding values for when the cos graph equals a half and negative a half. Hope this helps.